Alright, so what we want to do is we want to look at summations. And summations are a way of talking about addition. And we're going to have to sum a lot of things in statistics. Usually we use it to find an average of values or a total number of objects. We count a lot of things, and sums are the way we do it. But counting a lot of things can get a bit odd. So for example, I could have something I'm tracking like cars. Not cars, toy cars that children in an elementary class own. And so, John has 2 cars, Kenesha has 3 little Matchbox cars, Joseph has 0, Leslie has 1, and so on. We have some variable that represents the cars that each student in the class has owned. And I want to do statistics on this, so I want to add all of this up. Now, we might have this in a spreadsheet, we might have the data stored somewhere, but to talk about it, we don't want to carry around this sum, especially once we start getting, like 20 or 30 of these. We don't want to carry this around everywhere. So in statistics, we use the Greek letter sigma, and it's the capital sigma, and it's an S for sum, or to add. And what we will do is put the variable here, and it says add all the variables. Now there's another way you'll sometimes see this, especially if you look at other resources, where it will say, we'll have a little I equals 1, and then it'll go up to some number n, and it'll say x with a little I down here. And what this is a way of keeping track of your x's. So I could say, when I come in through here, I'll show you what this expands out to. It says, let's see, how many do we have here? We have 1, 2, 3, 4, 5, 6. And so n equals 6. There are 6 things. The number of things are 6. So I could say that this sum is I equals 1 to 6, x sum I. And what that does is I start on 1, and I go x number 1 plus x number 2 plus x number 3 plus x number 4 plus x number 5 plus x number 6. And this little subscript is a way of saying which one, right? This is my first one, this is my second one. It's a marker or a name to tell me which value to pull out. And I have a tendency to write it this way. I work with things that have a lot of different names or columns and data, and so knowing exactly where I am, this is good. Your book's going to use this, and it means the same thing. This says add up all of my x's. And so in here, when I say, hey, x1 was 2, x2 was 3, the one in the third place was 0, the one in the fourth place was 1, the one in the fifth place was 3, and the one in the sixth place was 4. Writing it like this, or this, is a compact way of carrying all of this around. And if I define something that uses a sum, I don't have to worry about how many things there are or what the particular thing looks like. So let's look at an example. I have some variable, x, and in my values for x I have 1, 2, 3, 4, and 5. I added something, and when I go out and count it, whatever my variable x is, this is what I have. And so I want to find the sum of all of my x's. And so the sum says I come up here, I look at what's in my variable, and I say I add the first one to the second one, plus the third one, plus the fourth one, plus the fifth one, or I get 6, 12, 15. Because 1 plus 2 is 3, 3 plus 3 is 9. 9 plus 4, wait, that's not 9, that's 6. 3 plus 3 is 6. 10, 15. Alright, then let's look at a couple others. I could have some other variable. I'll change colors for some other variable. I'll go yellow here. Some other variable, we'll say it's y. And in my values for y, I measured something that I owed 5 of. And maybe this is my my finances for the month. I owe $5. I get in 4. Sounds about right. Don't spend anything, don't make anything. And I want to find the sum, that's what sigma is, of y. This says grab all the values for y and add them together. And so, let's see, negative 5 plus 0 is still negative 5. Negative 5 plus 4 is negative 1. Negative 1 plus 9 is positive 8. And positive 8 plus 17 is 25. And so we're able to work our way through tables of values. One of the things you're going to see a lot of sums coming out of tables where we have to do different things with data. So let's say I have two values. I have some frequency, which is a fancy way of saying I have some number of things m. And I go out and I look for things with the m value of 11, 9, 8, 10, and 12. And they're matched with 2, 4, 5, 3, 6, and 2. Now because this data came together in a column, these are paired. And so each column represents a pair of data that has come together. And so I could talk about the sum of my scripted x's, which is equal to 2 plus 4 plus 5 plus 3 plus 6 plus 2. Or let's see, 6, 11, 14, 20, 22. And I can also talk about the sum of my m's, which is 12 plus 11 plus 9 plus 8 plus 10 plus 12. So 23, 32, 40, 50, 62. And of course what's nice is we have calculators, right? I have to talk to kind of show what we're doing here, but you can grab your calculator and you can type in all of these and get the sum. Well, sometimes we might want to find out what the sum is of my f times my m. And so I can multiply. Remember, these come in pairs, and this is why I keep the little i's. Because if I kept the little i's in here, I, from I equals 1, 2, 1, 2, 3, 4, 5, 6. When I pull these out, I know I want the f in the first place and the m in the first place, because my little i's tell me that. Whoops, they're not added though. They're multiplied. So I have 2 times 12 plus 4 times 11 plus 5 times 9. So notice how this multiplication is telling me to multiply each pair of these, and then the sum is telling me to add up. And our order of operation says do the multiplication first, then do my addition. So plus 3 times 8 plus 6 times 10 plus 2 times 12. And so let's do my multiplications first. So I'll write out all my multiplications. And let's see. 24 plus 44 is 68. 68 plus 45 is 113. 113 plus 24 is 137. 197. 221. Calculators, people. Alright, I'm the professor here. I have to try to know what I can do. Alright, so we can also take a value and do a correction. And so let's say I have a table of values here. Some measurement was taken. Let's say some measurement was taken using a bad measuring technique, but they all use the same bad measuring technique. And so I need to add up the total distance traveled, but I have to subtract 2.1 off of it because we started from the wrong place. Right? Let's say we're measuring something like a piece of cloth and we're moving it past a ruler, and so we keep measuring like patterns on the cloth or something, and we want the total distance. And every time I measured, I was actually accidentally measuring from here because of how it was folded, and so I was off by 2.1. And so or over by 2.1, I guess I should say, because of the way it was folded. And so I have to correct each of these measurements by 2.1. Well, I can do that. I can say, sum all of these up and subtract the 2.1 from each one. And so my sum says 8 minus 2.1. Grab my first thing, put it in, plus 12 minus 2.1, plus 13 minus 2.1, plus 9 minus 2.1, plus 7 minus 2.1, plus 4 minus 2.1. And so I have a way of writing, I need to correct all of these by 2.1 and then add up the total. Let's see, that's 5.9 plus 9.9 plus, what's 10.9 plus 6.9. 0.9s always get me because they're right around a boundary. Plus 4.9 plus 1.9. And let's see, 14.8, 15.8. I got to run to the calculator. So let me type this in. And I get 40.4. And yes, using a calculator is appropriate, right? We don't have to do all of our math in our heads or out by hand. And so this symbol, the uppercase Greek sigma, and this is the uppercase one, means sum. And whatever comes after it, in parentheses, you work through the list of things you have and you add them up. Until you run out, until you get to some endpoint. And so it's a nice compact way of carrying around multiple things that will add.